So we're going to go over 6 and 7. And then we have a couple things to do in the notes, but today's a pretty easy day, so we should be able to get through the notes pretty quickly. You're going to have a new assignment from your notes, but seriously, we're going to get through pretty quickly. So then you can work on your 3 assignments that are due so far. The math load is around the room. Have you finished that and turned it in? The synthetic worksheet, which you got yesterday, we did a couple of them, like 3 or 4 together. I think 3. We did 3 of them together. So you only have 7 others you have to do on your own. And then there's, like I said, there's going to be a new thing from our notes today, but it will literally fly by if you pay attention. You can get that done. Okay. I've written too much on this page. It is everywhere. I don't know what's all around. I gotta scribble that out or something because this is distracting me. Okay, so we're supposed to somehow factor x to the 4th minus 6x squared minus 16. How many terms are there?
3.
So should you use grouping?
No.
No. So then I was like, okay, you can't group. Great. So why don't we pretend, and this is a trick that I genuinely forgot this morning. Why don't we pretend that we're not dealing with x to the 4th? That's the problem, is the fact that it's to the 4th. So why don't we let x squared be y? Why don't everywhere we see an x squared, instead we replace it with y? And if we did that, our problem would become y squared minus 6y minus 16. And suddenly you're like, well, maybe I can factor that. So my suggestion is everywhere you saw an x squared, replace it with y. So instead of having x to the 4th minus 6x squared minus 16, we'll have y squared minus 6y minus 16. Can we factor this? It should be an easy factor. Why do I think it should be an easy factor? That's true, but tell me about that leading coefficient. And that's one of the vocab terms we're supposed to go over today, so you're really good at leading coefficient. So the leading coefficient is a 1, 1 and 3, I heard you differently. So it's supposed to be an easy factor, so I know this is y, and this is y. I just need to know the other 2 numbers.
Y plus 2 and y minus 8.
And our trio is correct. Negative 2 plus 8 is negative 6. Negative 8 times 2 is negative 16. So those are the perfect things. You can have a point. Okay, I wanted to circle that and call that my answer, but we have a problem. What is the problem? I wanted to circle this and call it my answer. But that's not right. Why? What was our problem? What variables were used in our problem? We had x's. So now for the final answer, we need to convert back to x's. So if we go back to x's, what should this answer be? X plus 2?
Yes.
And x minus 8? That's close, but no cigar.
Oh, it's x squared. Both are x squared.
Both are x squared, because we said x squared was y. So everywhere we see a y, we have to replace it with x squared. So our answer is x squared plus 2 and x squared minus 8. We'll give our trio a point, but we'll also give every other group a point for just being alive. So anytime you see a 1 to the 4th, my thoughts are, can I make it back to an easy one where it's just squared, where I know how to factor, like we did here, going to y's, and then at the very end I converted it back. Okay, number 7 I've written all over, so it's a hot mess. How many terms are there on number 7? 4. There are 4 terms, so what does that mean I'm supposed to use? What am I supposed to use? I heard you read first. I'm supposed to use grouping. However, there's something else I should do first. Factor the what?
Factor out the group.
Okay, so Mackenzie said it, and she said the number for me. There is a GCF in our problem we should pull out first, which is 2. So let's go ahead and pull 2 out of everybody. And if we pull 2 out, we're left with x to the third plus x squared minus x minus 1. Does everyone go with pulling out that GCF of 2? So pulled out a 2 out of everybody. But inside those parentheses, which I'm going to turn into brackets, just to keep my life a little easier. Inside those parentheses, I still have 1, 2, 3, 4 terms. So if I'm trying to factor inside those parentheses, I'm still going to try to use grouping. So I'm going to make one group with the first 2 terms, and a second group with the second 2 terms. What is the GCF I can pull out of that first group?
X to the second minus
And what would you be left with?
X and 1.
Arturo, you can have 2 points. Table 6, you being 1 and 2, still all the points. So x to the third, x squared, he knew they had x squared in common. And then he was left with an x plus 1. That was beautiful. What should we factor out of the second group?
Factor out a negative 1, and you'll be left with an x plus 1. And that's it would be x squared minus 1 and x plus 1.
When you're on my nerve. Okay. So Arturo said with that second group, Arturo said with that second group, they were both negative. So he pulled out a minus 1, which changed both their signs. It used to be a negative x, now it's a positive x. It used to be a negative 1, now it's a positive 1. These 2 match. So we grouped correctly. That's how we got this. X squared minus 1 is how we got this. And you would think Arturo is done because he's definitely done all the work for us. That's why he's getting another point from me. But sadly, this is not the final answer. There's still more that we could do.
Doesn't.
There is more that we can do. No, we're going to leave that till the outside. That's not the problem.
Is there another example?
Square.
There's another.
Square.
Miss Brister is the star student yet again.
What's she saying?
You have the difference of 2 squares.
Look at this one.
That's the difference of 2 squares.
Isn't one a perfect square?
I said something about square.
You don't want a perfect square. So the 2 is fine. The x plus 1 is fine. Our issue is with what I've highlighted. We can break that down further. X squared minus 1 turns into what? The difference of 2 squares. You did the first number 5 the other day. It was 4x squared minus 25. You broke it down already. This one should be a super easy one. So it's, what is the answer? It's taking so long. No, you can't. She said it. I heard her.
Minus 1.
Yeah, it's x minus 1 and x plus 1. Hey, to be honest, did you hear her? Okay, 3 and 6 here. Okay. So I'm with you. I thought we were done, but we weren't. Okay, we're going to try to do 8, 9, and 10 tomorrow. We'll do 8, 9, 10, and 12 tomorrow. Let's go ahead and be brave and get 11 out of the way. Let's look at 11. I'm going to leave that first term alone, but in that second term, I need to raise everyone to the second power. So I'm going to leave the negative 2 x squared y to the negative 5th alone for the moment. Could I go ahead and punish the y? Yes, I could. I'm just being lazy, so I'm not going to yet. One thing at a time today. Instead, I'm going to go ahead and raise everybody to that second power. So 3 to the second power is 9. X, negative 2 times 2 is negative 4. Y, 7 times 2 is 14. Are there any issues with the blue? Okay, so now what am I supposed to do? What's the next step? I'm going to go ahead and multiply both, but that is right. I've got those negative exponents. I could go ahead and punish them, but I'm not going to. I'm going to go with our truest suggestion. So negative 2 times 9, negative 18. I have x to the what power? So when we multiply, what do we do with our exponents? Add them. So our chair originally said negative 8. That would be wrong, wouldn't it? What should the answer be?
Negative 2.
It should be x to the negative 2. And then it should be y to the
Y to the 9.
y to the 9. Our chair get another one. We can't have negative exponents, so that's not the final answer, is it? You want to tell us the final answer so our chair doesn't get the point? Which one are you mad at? Yes, 4 to the point. We're going to let 3 finish it before you get the point. Okay. Paige and Mackenzie agree. We're cool with the negative 18 and the y to the 9. 1 lose a point. 6 lose a point. Our issue is the x to the negative 2, so we've got to punish it and put it to the bottom. And that's our final answer. Are there any questions about that one? Okay, we need to go to our notes. We have covered past few days long division and synthetic division. We're not on long division today. We're not even on synthetic division today. The next page in your notes says practice. Now there are 20 problems on that page. There's a lot of problems. Now, you could I like that one. You get a point. You only have to do the evens. Okay, so number 1, I'm going to talk about the odds since you're in charge of the evens. On number 1, we're supposed to combine our like terms. That's no big deal. Everyone can do number 1 or like number 2. That's fine. Number 3, there's a subtraction sign. You can handle that kind as well. Number 5, you would distribute. I'm pretty sure you can handle it. Don't forget about your rules of exponents. I'm going to practice 1, and I'm going to let that be number 7. Now, number 7 is no different than number 5, other than it's got more terms. So when I do 5a squared w to the 3rd times a squared w to the 6th, I add my exponents and I get 5a to the 4th w to the 9th. And I've already distributed to the first term. Now when I go to that second term, 5 times negative 3, I'll get negative 15 a to the 2 plus 4 is 6, w 3 plus 2 is 5. And then when I distribute to that last term, 9 times 5 is 45. A squared, a to the 1, I get a to the 3rd. W to the 3rd, w to the 5th, I get w to the 8th, because 3 plus 5 is 8. So it's really easy. It's just keeping up with your exponents. You've got to remember if they don't have one, it's an understood one. Otherwise, life should be good. If you want to put in the understood one, you can. That way you make sure you do 2 plus 1 is 3 for that last term. That makes sense. That's all you gotta do.
So this ain't like the, what we gotta do, like, what's it called?
He's want one like number 9 where you have to FOIL and it be something complicated.
No, this the, what's that division?
No, we're not doing synthetic or long division on these at all. These are all practicing adding, subtracting, and multiplying. The ones that they get stuck on are the multiplying. What should I use on number 9? What acronym am I supposed to use on number 9?
Oh, actually.
3. You're supposed to use FOIL. And I know most of us know how to FOIL, but seriously, we're just checking our rules of exponents. So first, b squared and b squared, when I multiply, I add my exponents. So it's going to be b to the 4th. Outer plus 4v squared. Inner minus 6v squared. And then last, minus 24. I combine my like terms. And I call it a day. Number 11 is just as easy, and so is 13. But you probably won't want to work one like 15, 17, or 19. Why are we not using FOIL on 15, 17, or 19?
They don't have what's it called?
They don't just have the 4, yes. It's not 2 binomials. Here we have a 1, 2, and a 1, 2. You can have points there. Down here we have a 1, 2, and that's not a 1, 2, it's a 1, 2, 3. So we can't use FOIL, we're going to have to distribute. We're going to have to distribute. Now, as for 17, I'm going to do 15, but as for 17, you could, since it is, I could FOIL with the first 2, and then distribute with the last. I really have a couple options on 17. But 15 and 19, I'm pretty set in stone. I have to send X to every single person in that second thing. And then I have to go back and send Y to every single person in that second thing. We've done some like these before, but it was before Christmas, so I'm going to do this one to remind you. X times X squared, I add my exponents, I get X to the 3rd for the first one. X times negative 3xy, I get negative 3x, 1 plus 1 is 2, so negative 3x squared y. And for the last one, x times 2y squared, I get 2xy squared. Is everyone cool with the distribution of the x to every single person? Okay, now we've got to distribute the y. So it was y times x squared. I'll get x squared y. It's y times negative 3xy. So it's negative 3x, y to the 1, y to the 1, that adds to y squared. And then last, y times 2y squared. I get 2y to the 1 plus 2 is 3. Are there any questions about the pink?
That's it.
Well, why is that not it?
You gotta combine all of them together.
Yeah, there are some like terms that we could put together. Otherwise, yeah, Tyreek, if you've gotten this far, I'm pretty happy with you. I'm not gonna lie.
My breaker.
But
There's negative 3x squared y and x squared y, and then there's 2xy.
okay, so let's one thing at a time. So x to the 3rd doesn't have a match. Archer is right. Negative 3 plus 1 is going to be negative 2x squared y. He wins on that. Then he said
2xy squared and negative 3xy squared.
so 2 minus 3, I get negative 1. So minus x y squared
And then it's plus 2y.
plus 2 out of the 3rd. And that's how Arturo is getting all the points. Arturo has 100 points. That's fine. That's squared up, yeah. You do 17 Punnett as well, or do you FOIL on these ones?
I did Punnett squared here, and then when I get that answer, I Punnett squared with that.
I'll give her that. Okay.
Yeah, that's what.
I'm great with that. Okay, so back to the beginning. Chapter 5 is on polynomials. 5.1 was on adding, subtracting, and multiplying like this. You already took and passed the test on it, but that was a long time ago. So your homework is going to be the even ones to try when I stop rambling. Because that's really what you're going to have to do today. Now, should you already know how to do those? Yeah. But do everyone need extra practice? Absolutely. Okay, if you have a question about those, I'll walk around and help you with it in a few minutes. Flip to the next page. That's what our actual, what we should learn today is, because, no offense, we already knew how to do that page. Okay, so, starting tomorrow, we're getting into how to graph polynomials and what their graph should look like. One laser point. Starting tomorrow, we're getting into how to graph polynomials and what their graph should look like. When I see the degree and the leading coefficient, I kind of already have an idea about how my graph is going to look. It reminds me of when we did parabolas, because we used to say, if I asked you to graph this, what could you tell me about that parabola? Is it stretched? Is it shrunk? Did it stay the same? Alright, I'll give you a couple examples. Didn't the x squared plus 4, because it's a positive 1 in front, it stayed the same? And then the plus 4 meant it picked it up and moved it up 4. So it was the same and up 4 from the vertex, from the origin. And this one, because it has a 7.
Ms. Conte?
Yes, ma'am.
May I have Zach Berry Hill to the main office?
Yes, ma'am.
Thank you.
Does the 7 make you fat or does the 7 make you skinny? Yes. Fractions make you fat. So the 7 would have made us a skinny graph. And then we don't have any up, left, right. We don't have anything like that. So we know it's skinny, but it's still going to be at the origin when it starts off. And then our last one, with that minus sign on the outside, what does that minus sign on the outside do to my graph? Yes, so it flips it. And then that minus 2 on the inside means we move left or right 2. And the plus 1 on the outside means we move up 1. Thank you. 3 get a point, 6 get a point. Okay, you were supposed to, you're about to lose all your points. Why am I talking over you today? You were supposed to remember that, and when you see the equation, you know stuff about the graph just by seeing the equation. Right? Well, that's the same sort of thing that's going to happen today, but clearly we're not just doing x squared. We've got x to the 6, x to the 7, we've got lots of x's. Okay, so the degree and the leading coefficient tell us a lot about our graph. The same way, if we have a number in front, it told us it was skinny with x squared, the same sort of thing is going to work. A number in front is going to make us skinny. A fraction in front is going to make us fat. So we've got so the leading coefficient, that's the number in front, is going to help us know whether or not we're fat or skinny. So that's why we need to know it. Plus, it helps us know if it's negative, we might be flipped. So we need to see the leading coefficient. And you're like, how do I find the leading coefficient? The leading coefficient is going to mean the number in front of the highest exponent. Number in front of the highest exponent. So the degree has to go with the highest exponent. The degree of our polynomial, look for the highest exponent. Okay, so on number 1, what's our degree? Our degree is 6 because our highest exponent is x to the 6. And what's the leading coefficient? 11. So I know about my graph, and it's going to be made kind of stretched thin because of that 11. So seriously, the degree is the 6, the leading coefficient is the 11. Now, a lot of these are set up nicely for us where they already have the largest exponent in the front, but that's not always the case. So let's just be careful. So on number 2, what's the degree? 6, get a point. What's the leading coefficient? Every group can have a point. Okay, number 3, what's the degree? It is 7, and what's the leading coefficient? And now we finally see a negative, or number 2 is a negative as well. So not only is it stretching our graph, whatever this weird graph is supposed to look like, but it's also flipping it. So whatever it was supposed to look like is now flipped upside down. Okay, the degree of number 4, you can have a point for that. And the leading coefficient is the negative 12. Okay, is everyone cool with this? Well, then let's finish it out while we're at it. Oh, no. We get to number 5. What happens? We would actually have to distribute, which is why we have to practice the ones that we're practicing on the polynomial page. So we're actually going to come back to number 5 as of tomorrow, because I don't think until we practice the page that we just talked about where you're going to do the evens, until you practice that, I doubt you can guess the answer. Now, while I say that, it's not necessarily completely true. I know in my head that x to the 3rd is as high as it's going to get for this middle guy. X squared is high as it's going to get for the last guy. I've got this 1 in front. 3, 2, and 1. 3, 4, 5, 6. My degree is going to be a 6. So I know the degree. Now, would it help me to work it on out? Probably. But again, I know I have an x to the 1. When I factor all this out, the x minus 7, whatever, I know the highest it's going to have is an x to the 3rd. And I know the highest the last one's going to have is an x squared. So in my mind, I'm like, oh, okay, 3, 4, 5, 6. The highest it can be is x to the 6. Now, does that tell me the leading coefficient? No. Do I need to know the leading coefficient? Yes. But can I go ahead and guess the degree? Absolutely. So if I guess the degree on number 8, for instance, what would I guess? I know I got this x here. What's the highest it's going to go when I, why would it be 5? Okay, so she's trying to make life complicated, and so is Hunter. I know when I factor it all out, isn't the largest thing I'm going to get out of this x to the 3rd? I'm not going to get higher than 3 because it was raised to the 3rd. I got an x to the 1. 1 plus 3 is 4. The degree is going to be a 4. Can someone tell me what the degree could be on number 6? Now, I keep saying could be because there's always the chance of when our churro was making us combine like terms, what if some of our like terms canceled out our big guys? There's always that potential, I guess. Okay. 6 is kind of hard. Let's do 7 first. What would be the degree on number 7? Yeah. So x2, x1, the highest it's going to be is a 3. 3 and 6 get a point. And then on number 6, what's the highest degree we can get on number 6? Yes. You can have a point there. So she said 3 plus 4 plus 1 plus 2, 4, 5, 6, 7, 8, 9, 10. The degree is 10. Now again, do I actually need to work it on out to figure out leading coefficient? Probably so. Probably so. Am I going to change my mind by tomorrow? Probably so. Of actually working it out because I always have my handy dandy calculator. And there's one other thing I should probably say about the degree before I stop rambling about degrees and leading coefficients. And that's what we're really going to get into tomorrow. If you know the degree, you know what the graph should look like. If you know the degree, for instance, is 2, you know your graph is either a happy or a sad parabola. If you know your degree is 1, you know you've got a line. It's either a positive or a negative slope, but you've got a line. In the same way, when I see degree of 6, I can picture a certain graph in my head. And the reason this happens is because the degree tells us how many times we could possibly touch the x-axis. So with parabolas, our degree was 2. At most, it could touch 2 times. So on number 1, our degree is 6. If we were to draw a graph, at most, this weirdo graph could touch up to 1, 2, 3, 4, 5, 6 times.
Ms. Compton, can
Yes,
I
ma'am.
have Tyreek Bevins to the main office?
Yes, ma'am. Now, I'm not saying for sure my graph looks like this, but I'm saying at most, since my degree is 6, my graph could at most touch the x-axis 6 times. So that degree kind of tells us how many zeros are possible. So that's the one note I might make to myself. Degree, it indicates how many zeros are possible. Now, we've had parabolas that never touched at all. And we've had parabolas that touched once or parabolas that have touched twice. The degree was 2, it could touch up to 2. So if the degree is 6, it could touch the x-axis up to 6 times. Okay, we are going to call it a day there. I swear we'll get back to the rest of it tomorrow. You can work on the page before you have all the evens to go for. Yes.